Now, let's look at a few interesting things that we see now. For instance, let's look at the amplitude, because that's very important. When the quantity omega L minus 1 over omega c equals 0, then the amplitude has its maximum value. Because when this is non-zero, the denominator is a larger number, and we have a smaller amplitude. And this idea that the current can reach a maximum value when we solve this equation, omega 1 over the square root of LC. Now recall, let's say this is for the maximum. That is the underlying angular frequency of just a pure LC circuit that's not driven. And when our omega is equal to this value, the current has its maximum value, and the phase is 0. Now that's very interesting. So let's explore this special case, which has the name of resonance. And what we'd like to do is look at how that amplitude, I naught, is a function of our driving frequency, omega. So here on our simulation, let's look at the current response. And you'll notice that there's a little phase shift, that the voltage blue is peaking before the current green. And we have a certain amplitude for the current. Now let's increase the angular frequency. And as you see at omega, we only have a limit of 500 radians per second. But you'll notice that as we went to higher omega, that this term is dominating. And so in the denominator, we're having a larger denominator, and the amplitude of the current gets a little bit smaller. Now, if we set omega equal to infinity, we'd expect this to fall off. And remember, we recall that this quantity is maximum when this quantity omega L minus 1 over c is 0. So we had omega max is 1 over the square root of LC. So here we have the value 1 over LC. And as we decrease the angular frequency, you'll notice again that the current is increasing its magnitude until we have a value when they're in phase at resonance. And then we'll just go below resonance. And as you see, the current is dropping off in magnitude as we get down to smaller and smaller omega until we're at 0, and there's essentially no current. So I'm going to put it right back at resonance for the moment. And what we have here is a functional plot that gets bigger until we get to resonance and then falls off and goes to 0. And this was our maximum value. And you can see at the maximum value, we have just V naught over R because this term is 0.